Welcome to Graphing Linear Inequalities, section 3.5. Now, there's only 11 questions, but the issue with this section is that there's a lot of steps that you have to go through to answer these questions. So I'm going to start with problem 2 because problem 1 is one of these select type things that you just cannot get wrong. Okay, there's only two answers there. They give you two ways to answer it. So uh, it's going on to real math on problem number 2. Decide if this ordered pair is a solution to the inequality. Now, what makes this an inequality is the fact that there's a greater than or an equal sign inside the expression. And what happens then is there's just not one answer that makes that true. If there was an equal sign, there would be one answer, one x and one y, that you could plug in to make the expression true. But when there's a greater than, there's a whole range of values that can make that true. So here in particular, what they're doing is that they're picking a particular point here, and they're saying, if I were to plug that point into this inequality, does it work? Does the expression come out true or false? So what I'm going to do is I'm going to write the inequality down and say, well, x minus 5. Okay, so this is your template, and what they want you to do is plug in this point. That's x. Okay, so I'm going to follow the template. 6, and x is minus 1 over 6 minus 5, and that is supposed to be equal to the number 2. Y is 2. So let's do the math and see what happens. 2 is greater than or equal to, well, 6 times 1/6 is 1, negative 1, because those 6 cancels, minus 5, and so what I have here is 2 is greater than or equal to minus 6. Yeah, that's true. Sure. That's true, so I'm going to say yes, it is true. Okay, so that's what you do for those kind of problems. Now we're going to start graphing, and boy, what the heck does this mean? This looks kind of complicated. The first thing you're going to have to understand when you answer questions like this is this less than does not have an equal sign associated with it. This is just truly a less than. And so if that's a less than with no equals, do not pick a solid line. Okay? Any graph with a solid line would be wrong, because if there's a solid line in the graph, that means you want to include the points that are on that line. Okay, but there is no equals there. You don't want to include those points. So you want solutions that have have a dashed line, because dashed lines indicate no equality to the line at all. So right now, what I have here is two possibilities, B and D. By process of elimination, the solid line ones can't work because there's no equal sign there. So, and that's true for all the problems that you're going to do in this section when you're graphing linear inequalities. So which do we have? We have a 50-50 chance of getting this right. Here's how you do these type of problems. You pick a test point, what's called a test point, something called a test point. Let me just go over here and clear this out and start with a fresh sheet of paper so you're not distracted. File, new. Okay, and what we're going to do, of course, is copy this inequality down. 4/5 x minus 4. So what you're going to do is pick a test point. See, what happens is this line separates the grid into two regions. Okay, there's a top region and a bottom region. And what we want to do is pick the region that satisfies that inequality. So what I'm going to do is I'm going to say, well, let's pick a nice test point that doesn't require a lot of calculation on our part. If possible, and oftentimes it is possible, I'm going to pick 0, 0. See that point right there, 0, 0? And you're going to say, well, okay, pick 0, 0. TP, test point, equals 0, 0. Okay, so I've picked it. So what are you going to do with it? Take that 0, 0, plug it into the equation. By the way, that looks like a y. That's a 4. And see if it comes out true. So if x is 0, okay, this entire expression is 0. 0 minus 4 is minus 4. Y is 0. Okay, is that true? Is 0 less than minus 4? Nope. Nope, not true. So what does that mean? The region that includes that test point, this region that includes a test point, those points in that region don't satisfy this inequality. And if they don't satisfy the inequality in that region, it must be true that the opposite region must satisfy. So I'm going to go ahead and pick D for that answer. Okay? So the whole idea, so let's recant. Let's see if this is right. I'm sure it is. I think it's right. I've been doing it a while. The idea is you have a line that separates the world, and the world, I call it, is this graph plane. You got a line that separates the world into two parts. Top, bottom, left, right, depends on your perspective. What you're going to do is pick a test point somewhere in the world. Okay, I picked this guy, 0, 0. Okay, now 0, 0 is inside this region. I plugged any point inside that region works the same as far as an inequality is concerned. So I'm going to pick a 0, 0. I came up with zeros less than -4, and that is not true on Earth. That is not true. 0 is bigger than -4. So what you want to do is say, well, this region that includes the test point can't work. It must be the opposite side. That's the opposite side, and we just proved that that works. All right, let's try the next one, see what happens. You know what? I'm going to try something that has x's and y's, because x's and I'm going to try this one first, and then I'll go back, because it's actually easier and more fun if there's both x's and y's in there, and people tend to see that better. New, let's close this out. Close that out. Don't save. File, new. Okay. And okay, let's see what we're going to do. So what I'm going to do first is graph this. I'll just write down the expression. The inequality greater than 20. First thing you're going to do is come up with a line that represents the dividing line of the world. Okay, you're going to come up with a line that separates the world into two parts: the part that works and the part that doesn't. What am I talking about? Change this to an equals. Change this to an equals. Okay, I've changed it to an equals. That line right there separates the world. And you graph this the same way you graphed it in the previous sections. See, there's a lot of overlap here. And, let's try something here. I noticed that 4 and 5 divide into 20. So what I'm going to do is say, I'm going to use the intercept method, where I say if x is 0, see, I need 2 points. Same thing, that still hasn't changed. I need 2 points to draw this line. So if x is 0, I'm left with 5y equals 20, and if I divide by 5, I get 4. Now what I do next is say, well, if y is 0, 5 times 0 is 0, so this entire term goes away. What you're left with is -4x equals 20, and divide by -4, you get x is -5. Okay, now we got our 2 points. That defines the world. Let's come over here, click on this, and draw the line like always, but we never did this before. Okay, when you draw a line, it defaults to a solid line because we never touched it before. Now we got to worry about, do we want a dashed line or a solid line? Now, from what we talked about before, if there's no equals in the original inequality, see, there's no equals there, you don't want a solid line. You want a dashed line. Okay, and see what happens. But the process of drawing the line is the same. 0, 4. Graph these 2 points. 0, x, 4y. Then we've got negative 5, x, 0. Okay, see what it did? It made a dashed line. I don't know if you could see that. Let's see. I don't know if you could see that. We can make it a little bit bigger. Yeah, now you can see it. Okay. Let's go back down. Okay. All right. So what's next? What's next is, okay, it's not enough to divide the world into the top and the bottom. We want to determine which part of the world its points, which part of the world contains points that make that true. And what do? Take a test point. I always go for the 0, 0. The 0, 0 test point right there. So take 0, 0, TP equals 0, 0. Okay. Plug it into the original inequality. And 0, 0 is great because you got 0 plus, when I plug in x as 0, that term goes away. If I plug in y as 0, that term goes away. You're left with 0 is greater than 20. Is that true? No, it's not true. Exclamation point. So what that means is the region that includes this test point is the wrong region, because if that produces a no-go on the inequality, then any other point would produce a no-go. So it must mean that the opposite side must be true. And how you select that opposite side? You got this little paint can right over here. See this little paint can? Click it. Go up here. Click it. Go up here. And just click it, and it dumps some paint in that area. And let's see if that works. Okay. Okay. Now, why didn't that work? Okay, 0, 0, 0, 0, 0 plus 0 is greater than 20. 0 is greater than 20 is false. Maybe the line was drawn wrong. Maybe the line 0, 5, 0, 4, and this is negative 5, 0. Oh, look what I did here. Look at this. All that work for nothing. This is what's wrong with math. Minus 20. I put down 20. Oh, dear. Well, hey. This would have worked if that were 20. Sorry about that. So let's think. Well, we wasted a little bit of time, but most of you are young, so you got plenty of time to spare. Let's clear it. Start over again. Clear all the objects. Okay. All right, and let's start let's go back here and start with a new fresh sheet of paper. Clear it, don't save, and let's wipe the slate clean. Wipe the slate clean right here. Start over again. So, okay, different problem. Negative 4x plus 5y. Equal, greater than negative 20. Okay, that changes things a lot. But the technique doesn't change. You still need to draw the dividing line between the true and false worlds. So what I'm going to do is to change that to an equals. Negative 20. That's going to kill me. All right. I need 2 points to draw the line. Get those points ready right there. And I'm going to say, hey, if x is 0, x is 0, 5y equals negative 20. That would be negative 4. This drastically changes the line. And if y is 0, the second coordinate, if y is 0, then x is negative 5. No, x is positive 5. Jeez, I can't get it wrong twice. Because if 5y is 0, negative 4x equals negative 20. So if I divide by negative 4, you get a positive 5. Okay, let's draw that. Pick a line. Make sure, because of the problem, because there's no equals, you have a dashed line, because we don't want to include the points that are on that line. It's much like saying you have the Connecticut River, and the Connecticut River separates West Springfield and Springfield. Points on the Connecticut River, it's vague as to whether who owns the Connecticut River. Okay, so you don't want to include whatever is inside the Connecticut River. We just want either side, but not including the river. I don't know if that makes any sense, but I wanted to give you another way of looking at it. So here, 0, negative 4. Click that. 5, oh, definitely change the graph. Okay. Now, just because it says, a lot of students do this, just because they have a greater than, they shade the top region, and that's not the way you do it. That doesn't necessarily always work, because greater than, you'd say, oh, it must be greater than the line. No, that's not true. You need to do the test point thing. And I always go for the test point of 0, 0. And I plug in my 0, 0, and I get 0 plus 0 is greater than negative 20. And that's true. That is true. That is true. So what you're going to do is take your paint can. First, draw that. Take your paint can. If it's true, that's the 0, 0 point. You shade the region that includes the 0, 0 point, because any point inside that region will work. Okay, so it's radically different from what we have just because of that little minus sign difference. Check your answer. There you go. Wow. Got to be careful. You think after all these years, I'd be careful. Now, I'm human too. Ooh, let's do this one. Let's do this one right here. This is a good one. Okay, let's make sure it's right now. Don't save. File, new. The problems with the x's and the y's tend to be easier than the problems with x's, but just x's and just y's. I don't know why. People just get all nervous with just one variable. But anyway, 2x minus 5y is less than or equal to, so that clues me in that when I draw the line, there better be a solid line. Okay, that Connecticut River analogy, I want to include the points on the Connecticut River. All right, there you go. Okay, what do I do? First thing, I need to draw the dividing line. So change that to an equals. And you do the same stuff we did in the previous sections. What you're going to do is come up with 2 points. Okay, get them ready. Okay, so x is 0. See, I noticed that 2 and 5 divide evenly into 10, so this technique will work great. If x is 0, calculate y, and if y is 0, calculate x. So if x is 0, 2x goes away. You're left with negative 5y equals 10. Divide by negative 5, you get negative 2 for y, corresponding y. Now, if I say 0 goes into y is 0, this term goes away. You're left with 2x equals 10. If I divide by 2, I got 5. So here we go. I can draw the dividing line. Click the thing. Draw a line. Make sure this is a solid line because the original expression had the equals. And just plot 0, negative 2, 5, 0 is that. There you go. Solid line. Now, do I shade above or below? And just because, and again, It may have worked out in the previous problem, but just because you see a less than, don't just blindly shade the bottom region, because there's going to be situations where that's not true. Okay, so let's see. What do? We take a test point, 0, 0. Plug in 0, 0. Why do I use 0, 0? Because it's easy to plug in zeros because terms go away. If x is 0, that term goes away. If y is 0, that term goes away. You're left with this. 0 is less than or equal to 10. Is that true? Is 0 less than or equal to 10? Yep, it is true. So the region that includes the test point needs to be shaded because all these points would work. Take your paint can, and you'll notice, take your paint can, click it. You'll notice that just because you see a less than, okay, don't shade the bottom because that's not the right answer. You've got to use the test point technique. There you go. All right. So that's that. And let's see. Let's start off with a sheet of paper. It's the same thing. This is the same thing. Don't save. File, new. Okay. Come down here. And it's the same deal. Y is greater than negative 2x minus 3. And I analyzed that, and I don't see an equals, so I'm going to be very careful when I draw the line that divides the world into two parts. I'm going to be very careful not to have a solid line, but a dashed line. Okay, I need to draw that line. I need 2 points. Okay, change that to an equals. Change that to an equals. If y is 0, not y, if x is 0, y's got to be negative 3. 0 times negative 2 is 0, minus 3, there you go. Now, when you have the standard form like y equals negative 2x minus 3, it might be standard form, but it's harder to say what to do. Well, if y is 0, what's x? Because you got a little calculation. I don't want to do much calculation. What I'm going to do now is just pick a value for x, number 1. Okay, now plugging in 1, you don't need a calculator. Negative 2 times 1 is negative 2. Minus 3 gives you a minus 5 for the y value. Now remember, I'm plotting the equals. So let's move this over here. Let's plot that line. It defaults to a solid line. You don't want a solid line. You want, because there's no equals here, I want a dashed line. Okay, so 0, negative 3, right there. Okay, 1, negative 5. Come on. Boom, there you go. Okay, I divided the world into top and bottom. There's the Connecticut River right in the middle. Now, do I shade above or below? Again, forget about greater than and then shading above. It doesn't work, and I showed you that in the previous problem. What you got to do is pick the best test point you can. I mean, I could have picked 1, 2. Okay, but then I got to start doing some serious math. Well, not serious math, but I got to do calculation. Why do you need to do calculation when you got a 0, 0 point? And what that basically says is, hey, if I plug in x is 0, I get minus 3 on the right, and then I plug in y is 0. Okay, you can't get any easier than that. Hey, is 0 bigger than minus 3? Yes, it is. True. In this case, because the 0, 0 is in this region, okay, and this region produces true values, I'm going to take my paint can and dump some paint on the top, check my answer, and look at that beautiful green. Look at that beautiful green that you see right there. All right. This is a technique. This is what you're going to do. And let me just take a look at what the next one is. Okay, a couple of word problems, and then we'll go backwards. The things I skipped. Okay, CEO of TM Solutions has determined that to remain in business, TM must ship at least 800 units monthly to its two distributors. Okay, if X and Y represent the distributors, the situation can be represented by the inequality X plus Y is greater than or equal to 800. Okay, yeah, okay, that makes sense. Okay, the long and the short of it is you want to plot this on this graph. That's all that is. So I think I could sneak that over here. X plus Y is greater than or equal to 800. Okay, good. Excuse me. I need to draw the dividing line. Forget greater than. I need to change that to equals. So pretend that you see equals there. What I'm going to do is then say, well, here's my 2 points. I think it's perfectly okay to say if X is 0, Y's got to be 800. And if Y is 0, I plug in 0 for Y, X is 800. I got my 2 points. Now I need to draw the line. Click. Line. Do I pick solid or dashed? I pick solid because there's an equal sign in there. Okay, it's already defaulted as solid, so I got here. The 0, 8 is right there. Okay, and 800, 0 is right there. So we have our two regions, above and below. What do we do now? Just because you see greater than doesn't mean you shade the region. It might work out, and you would have lucked out. I plug in a test point. Take your test point, 0, 0. There's your test point right there, inside this bottom region. If I plug in 0, 0, X plus Y is 0, bigger than or equal to 800. Nope, doesn't work. So what you do is you take your paint can, don't shade that region because that region contains the 0, 0. And that region we just showed can't work. You got to go up, up. Shade that region, the opposite region. That's an 800, looks like. Yeah, that's an 800. Check your answer. That makes sense. Any point up here, take any point up here. If you add this point's coordinates, it's always going to be bigger than 800. Okay, ooh, choose an ordered pair that's a solution. They snuck that in there. So basically what we're looking for is taking the X and adding the X and Y coordinates and making sure that it's bigger than 800. 500 plus 200, nope, not bigger than 800. 0 and 650, nope, not bigger than 800. Certainly not this one. This one here looks like 400 and 700 added together is 1100, so that's bigger than 800. Okay, I thought they'd sneak another. They had more real estate down there. I thought they'd sneak another problem. Well, they did. They did, those rats. Choose another ordered pair. Okay, all we're looking for is to take the coordinates and add them together and make sure it's bigger than 800. So I'm going with A. Right off the bat, there could only be one answer. 400 plus 400 is equal to 800, and that's included with the equal sign. Okay. Good job. All right, now what do we got here? Another word problem, and this word problem isn't all that involved, so let me just in case though, let me get a new sheet of paper, file new. File new, okay, and come over here, and let's see. Jim sells flowers for $5 a piece, okay, and vases for $16 a piece. Write an inequality that shows the possible combination of flowers and vases that Jim needs to sell in order to earn at least $80. Well, let's see. Let's take X flowers, okay? For every flower that you sell, you put in your pocket $5. So 5 times X is the amount of money you make on flowers. But of course, you got to put those flowers in a vase, so you got to sell Y vases, and every time you sell Y vases, you put in your pocket $16. So that's the sum of the money that you make selling flowers and vases. You want to make greater than or equal to at least It's okay to make 80, but it'd be really nice to make 1,000. Okay? You want to make that. You want to make sure that the money that you collect has got to be bigger than the 80 that you want. So I'm going to make sure I pick this guy right here. That looks like what I got. Nice. Okay. Graph it. You know you're going to graph it. Okay. Now how do we graph it? No problem. Draw the dividing line that divides the world into two parts, the haves and have-nots, the trues and false. You need to draw a line. So to draw the line, you need 2 points. Get them ready. And because 5 and 16 divides into 80, I'm not going to move these terms around. What I'm going to do is I'm going to say just keep it the way it is. If x is 0, this term goes away. I'm left with 16y is equal to 80. Remember, I changed that to an equal sign. That gives me 5 when I divide by 16. And then what I do next is, if y is 0, that term goes away. 5x is equal to 80. Divide by 5, you get 16. Okay. Let's draw that line. Draw the line. Okay. Line. Because it's equals, I make sure it stays solid. So what I can do is 0, 5. That's 1 point right there. 0, 5. Yeah, clear it. I screwed up. Good thing I found it now. That was 5, 0. Okay, do it again. 0, 5. That's much better. And the next point is 16, 0. There you go. Boom. All right. So there's your dividing line. We got the bottom. We've got the top. I'm feeling that the answer is the top, but we can't just do that. Okay? What you need to do is take a test point, plug the test point in. X is 0, y is 0 produces a 0 greater than or equal to 80. If 0 is bigger than or equal to 80, it's not true. 0 is not bigger than or equal to 80. So the region that includes the test point can't work. It must be the opposite side, which was what I suspected. Okay, that side there. Okay, so what have we done so far? What we've done so far is the last 5 problems. Okay, why don't we stop the video here, because the videos tends to get a little long, and we'll do the next video. We'll start with the first problems. Okay, I'll see you in the next video.